Today we're going to start solving inequalities. So the first lesson on inequalities is going to be on linear inequalities. So when solving linear inequalities, it's the same rules as equations, except when you are dividing or multiplying both sides of the equation by a negative number. Remember that when that happens in an inequality, you're going to have to flip the direction of the inequality sign, okay? Your answers are either going to be inequality statements, as you did in Algebra 1, or we're going to graphs as well, or interval notation. Now, interval notation is going to be our focus, and that's going to be part of our lesson today. So let's start just kind of refreshing your memory. One of the differences between an inequality and an equation is that an inequality is going to give you a range of solutions, whereas an equation gives you a set value for the variable. So notice here in your number line, right? Let's go to the first one, and it says x is greater than any number. So let's just change any number, and let's say x is greater than 3. How would that look on a graph, right? So I'm going to put 0 here and 3 here. You also want to think of the graph as approaching infinity to the right and negative infinity to the left. And so when you say that x is greater than 3, what you're saying is that x is all values that are greater than the value 3. So how we do that is we do an open circle at 3, and it's open because it's greater than 3 but not equal to 3. If it was equal, we would do a closed circle. And so if x is greater than 3, we know that x starts at 3, open circle, and it goes to the right, okay? So those are all the values that are greater than 3. However, in interval notation, what we're going to do is we're not going to do it on a number line because we don't want to draw number lines all day long, right? We're going to show that in the form of interval notation. So the open circle, okay, in interval notation is equal to a parentheses, okay? And a closed circle, which means equal to something, in interval notation is going to be equal to brackets, okay? So in this case, notice that our solutions start at 3 and go to positive infinity, right? Now, because 3 is an open circle, we're going to represent it with a parentheses. And infinity really isn't a set value, right? It's more of a concept, but it's just there's no set final number in infinity. So you're not really equal to infinity. So we do a parentheses anytime we refer to infinity as well, because it's not like there's a hard stop there, and it's not like it includes the last value of infinity. There's no value to infinity, right? So if it says x is less than any number, again, let's do 3 again. So here's 3, here's negative infinity, here's positive infinity, and if x is less than 3, then we're going to have an open circle at 3, and we're going to shade all the way to the left. So in interval notation, again, we always go in interval notation, we go from smallest to biggest or left to right. So negative infinity comes first and 3 comes second. Since negative infinity is not a set number, we always, again, we do a parentheses. And since it doesn't include 3, it's not equal to 3, we do a parentheses there. So that's how I would represent it on a graph, and that's how I would represent it in a interval notation. So let's do the next pair, right? So it says x is greater than or equal to a number. So again, I'm going to use 3 for both of these here. So again, here I've got the number 3. I have infinity and negative infinity. Whoops, not 8. I've got negative infinity. And so again, 3 is greater than or equal to that. So it's going to be greater than or equal. So this is equal to 3. And this represents greater than. So again, when I'm doing this, I know that my leftmost solution is 3 and my rightmost is infinity. Infinity always gets a parentheses, and because it includes 3, I'm going to give it a bracket this time. And again, on the other side, x is less than or equal to 3. So again, it includes 3 and it goes to the left for less than. And so I know the left is negative infinity. And so again, I go from left to right, negative infinity to 3. It doesn't include infinity, right? but it does include the 3. And so that's my answer in interval notation. Again, we're going to keep going. Now here, notice that my solution x is between 2 values. So what happens is, let's say, I'll give you a value here. Let's say x is between -3 and +3. So again, here's -3, here's +3, and it says that x is all the values in between, but not including -3 and not including +3. So I'm going to it's these values and these values. So notice it's kind of like the inside, the in-between of those numbers. So in interval notation, how I'm going to do that is, notice that the leftmost solution is -3, the rightmost is 3. So it's going to be -3 to 3, and because they're both open circles, they're both parentheses. So my solutions are all the values between -3 and 3, not inclusive, okay? Now, the same problem over here with the equal sign. Again, I'm going to do -3, I'm going to do +3, but I'm going to do a closed circle at 3, and then closed circle at -3 and a closed circle at +3. And I know x is bigger, right, than -3, so it goes this way, and x is less than +3. So again, it's in between these two, but it's inclusive. So again, I go from -3 to 3, but now I do brackets. Now, the last one is kind of interesting. Let's do, each one here. Let me give you some values for this. So x is less than -3, and x is greater than +3. So let's try that. So the first one says x is less than, so here's -3, here's +3, here's infinity, here's -infinity, right? And it says the first, let's tackle each one at a time. X is less than -3. So if x is less than -3, it's an open circle at -3, and it goes this way. Or x is greater than 3. So again, it's an open circle at +3, and it goes to the right. So really, I have two sets here of solutions, right? I've got -infinity to -3. I've got a parentheses and parentheses. And then over here, I start at 3, and I go to +infinity. And whenever we have multiple sets of solution areas, we connect them, well, it doesn't really look like that. We connect them with a U, that's a union, which basically means all the solutions, the solutions, all the ones included here and here. So we call it union. And that's how we would write those two areas of solutions. So again, let's say we do this over here. And again, we'll say -3 and 3. So again, we have -3, +3, we have infinity and -infinity. And again, x is less than or equal to -3, so it's a solid circle, and then it goes to the left, and then this is a solid circle, and it goes to the right. So again, this is still a parentheses with the -infinity, but at the -3, it would be a bracket. It's union. It's a bracket at 3 because our answers include 3 and -3, and then infinity with a parentheses. So I hope that helps a little bit. So now let's actually solve some problems, and we have to put the answer in interval notation. So when we're going to solve these problems, we know that what we have to do is we have to get the variables. These are all linear, x to the first power. So we're going to have to put all the variables on one side and all the numbers on the other. So we isolate the variable and solve for x. Just remember that whenever you divide or multiply by a negative number with an inequality, you've got to flip the sign. So I'm going to start by subtracting 3x from both sides. I'm going to get 2x minus 7 is greater than 9. I'll add 7 to both sides. 2x is greater than 16, and I'll divide by 2, and I'll get that x is greater than 8. So obviously on a number line here, here's 8, here's infinity, and if x is greater than 8, then I know that it's an open circle here, and it goes this way. Now notice it wanted me to solve. It wanted me to graph. And then it wants me to put it in interval notation. So my leftmost point, my lowest point in my solution is 8. My highest is infinity, obviously, and both of them get parentheses. And so that's all 3 solutions there. Go to the next problem. Again, same thing. I'll subtract 2x from both sides. I'm going to get 5x minus 3 is less than or equal to 7. I'm going to add 3 to both sides. I'm going to get 5x is less than or equal to 10. And I'm going to divide both sides by 5, and I'm going to get x is less than or equal to 2. Then I'm going to do my graph. And again here I've got 2, positive infinity, negative infinity, and it says that x is greater than, or sorry, x is less than or equal to 2. So equal to 2 or less than 2 goes this way. And so that's the graph. And again, in interval notation, I know I'm going to go from negative infinity to 2. Negative infinity always gets a parentheses, and 2 will get a bracket in this case because it's equal to it. And so, again, there's my solution in interval notation. Keep going here. Now notice in this problem we have a fraction. You can work with negative 3/2 if you like. I personally do not like to do that. So what I like to do is multiply by my least common denominator, which would be 2. I'm going to multiply everything by 2. That's going to give me 2 minus 3x is greater than or equal to 2x minus 8. This to me is a much simpler problem. So I always like to have my variables on the left side of the inequality because we always read them from left to right. So I'm going to subtract 2x from both sides so that my variable stays on the left. And then I'm going to subtract 2. I'm going to get negative 5x is greater than or equal to negative 10. And here notice that I am dividing by a negative 5. And when I do that, that means that I have to flip my sign, and then just negative 10 divided by negative 5 is 2. So this is my numeric solution to this problem. If I go to graph it, again, I've got 2, positive infinity, negative infinity, and I see that it is less than or equal to 2. So it's going to be a solid circle, and it's going to go to the left. And so when it comes time to put this in interval notation, it's going to be negative infinity to 2. 2 is going to take a bracket because it's included, and infinity always gets a parentheses. And so here are the 3 solutions that they're asking for, or the 3 ways to show a solution. And then again, I'm going to go to this last problem over here, and we've got, again, a fraction. So for me, it's just easier to multiply everything by 3. So I'm going to get 3 times 2 is 6, minus 5x is greater than 3x minus 18. Again, I'm always bringing my variables over to the left. So 6 minus 8x is greater than negative 18. Bring my numbers to the other side. Minus 8x is greater than minus 24. And when I divide both sides by minus 8, I'm going to get x is less than 3. So there's my solution. When I go to graph this again, I'm going to take my time, negative infinity, and positive 3. And if it's less than 3, it's an open circle at 3, and it's less than or to the left. And so again, when I go to write this in interval notation, I know I'm going from negative infinity to 3, parentheses at 3 because it's not equal to it, and parentheses at infinity. And there you go. So now we get to these problems where, notice, this is what's called a compound inequality. And we call it a compound inequality because really there's 2 inequalities in one problem. Now, there's a couple of ways to solve these, right? What this ends up really being, right, is it's 2 separate inequalities. It's this inequality. In other words, it's negative 4 is less than or equal to 5x minus 2. And it's 5x minus 2 is less than 7. And so it's that combination, or it's 2 of them. And so you could technically solve each one separately. So I could add 2, I get 5x is greater than or equal to minus 2, and then I could divide both sides by 5, and I could get negative 2/5. Now, I don't like the variable on this side, so I would rewrite it x is greater than or equal to negative 2/5 on this side. And I could do the same thing over here. So plus 2, I get 5x is less than 9. Divide both sides by 5 and get that x is less than 9/5. So those are my two solutions, okay? And what I would do at this point, let me kind of move this over here. What I would do here is I would do a number line, and I would kind of write these out. I've got negative 2/5 over here. I've got positive 9/5 over here. And I see that my thing says, again, x is greater than or equal to negative 2/5. So it's a solid circle, and it goes this way. And x is less than 9/5, so open circle, and it goes this way. So my solution is really, in here. It's this open circle, and it's this closed circle, and it's all the values in between that. Okay, so that's how I would graph it. Now, if I was to write this as in an interval notation, what I would do again is my leftmost solution is negative 2/5. My rightmost solution is 9/5. 9/5 is an open circle because it's not included in the answer, and 2/5 is solid. And so this would be the answer in interval notation. Now, a shortcut to this process here, I'm going to show you in the next problem, okay, just to kind of show you another way you could do it. Instead of taking this problem and seeing it, like, again, this one was, you had this first inequality, and then you basically had this second inequality. And that's kind of what I separated out, right? If you want, though, you can keep them together, and you're just kind of working both sides of this. So instead of separating this out and having one, and then separating this out and having another one, what you're going to do is you're going to work with this middle, and you're going to do this. You're going to say, okay, I'm going to add 1 to get rid of this in the center, and whatever I do here to the middle, I've got to do to the left, and I have to do it to the right. So what happens is this side here becomes negative 2, it's less than or equal to 6x, which is less than 4. And now I'm going to multiply both sides, or divide both sides by, or all three sides rather, by 6. Because I want to get the middle to be x. So I'm going to get negative 1/3 is less than or equal to x, which is less than 2/3. So now I already have my answer. This is my solution. X is between these two numbers, okay? It's kind of in a little bit cleaner format, and it's easier to graph. It's easier to really do everything from here. So notice that, again, I've got negative 1/3 here. I've got 2/3 here. And my graph says, or my answer says that x is greater than or equal to negative 1/3. That means it's this way. And it's less than 2/3. So it's all the values in between, right? Starting at negative 1/3 and ending at positive 2/3. Positive 2/3 takes a parentheses, and negative 1/3 gets a bracket. And so that's the answer in interval notation. And so it does save time. Again, you would have gotten the same answer had you just separated them into two, but a lot of students like doing these compounds in this format here. So moving forward, I'm going to do it in this format. So I'm going to start by subtracting 7 from all three sides. I'm going to get negative 6 is less than 2x, which is less than 4. Then I'm going to divide all three sides by 2. I'm going to get negative 3 is less than x, which is less than 2. So once again, that's my solution as an inequality. In the graph, it's going to be an open circle at negative 3, and it's going to be to the right, and an open circle at 2 and to the left. And so I know that's what my graph would look like. And in interval notation, it would be starting at negative 3, going to 2, and parentheses on both ends because they're both not equal to those numbers, right? Non-inclusive. And so we go to this last one. And again, I can still do the same pattern if I want. of eliminating the denominator. Again, since the denominator is 3, I can multiply every term by 3. So I'm going to multiply the negative 4 by 3. I'm going to multiply the 2/3 by 3. I'm going to multiply the x by 3. And I'm going to multiply the 5 by 3. Now that I have this, I'm going to start chipping away because this middle term has to just be x. So minus 2, and minus 2. Minus 14 is less than or equal to minus 3x, which is less than 13. Now I'm going to divide by negative 3. So I'm going to divide both sides by negative 3. Anytime I divide by negative 3, I have to remember that I'm going to have to flip signs. So this answer here is 14/3. I'm going to flip the sign. The middle is x. I'm going to flip the sign again, and this is negative 13/3. Now, again, we like to go from smallest to biggest, and notice that this is a negative and this is a positive. So I know that I'm going from big to small here. So I'm going to rewrite this. It's going to be negative 13/3. Notice the less than sign, the closed part of this inequality is facing the negative 13/3. So be careful when you flip it, you know, in the order that you do not mess up the inequalities, okay? And so again, this would be my solution as an inequality. In a graph, my solution, I would have negative 13/3 over here. I would have positive 14/3 on this side. And I know that x is greater than this one. So it's open circle this way. And this is a closed circle and less than, so it's to the left. And again, as an interval notation, I know it starts at 13/3 or negative 13/3, goes to 14/3. This side gets a bracket, this side gets parentheses. And those are the answers. Now we get to solving absolute value inequalities. And again, with absolute values, it's a little bit tricky. Now there are some kind of rules that if you happen to have an absolute value and you're talking about a less than or a less than or equal to, your answer is an and statement. So you're going to have an answer that's going to have the solutions in the middle of 2 points or multiple points. And if you have a greater than or equal, you're going to have an or statement. So like your answers are going to go in opposite directions in these, something like that. Whereas in this one, it would be more like, they'd come together like that. Again, we'll talk about it. I'll show you the differences. So when you get to absolute values, what we're going to do is we're going to break them into 2 inequalities, okay, from the very start. The first thing is, though, we have to make sure that before we do that, the absolute value has to be completely isolated on one side of the inequality. Nothing else can be there. And in these, there is nothing else. So we're going to analyze it. We're going to look at the question and say, can the absolute value of x minus 5 be less than positive 2? Yes, that's reasonable. It can be less than positive 2. So now that we know it's reasonable, we're going to set it up. And we are going to completely copy what's here, but we're going to add another side to this. We're going to take whatever this inequality is and we're going to mirror it right there, okay? And then we're going to put, since this is positive 2 here, we're going to put the opposite. We're going to negate it there and do the negative 2. So now it kind of is looking like a compound inequality, right? Once I do that, now I'm going to break it into 2 things. Negative 2 is less than x minus 5, and x minus 5 is less than 2, okay? And so all I did was I kind of took this part right here and I negated it on the other side, all right? So again, it's that little step there. Once you do that, you can now break it into 2 and you can get rid of the bars, okay? So now we're just ready to solve for x. So I'm going to add 5 to both sides, and here I'm going to get x is greater than positive 3, and I'm going to do the same thing on this side. And I'm going to get x is less than 7. So notice that x is greater than 3 and less than 7. This is my solution. When I go to my graph here, here's 3, here's 7, and it's going to be greater than 3, less than 7. So greater than 3 is this way, less than 7 is that way. And in interval notation, it's all the values between 3 and 7, but these are going to be parentheses. And so these 3 are the solutions, again, solving, graphing, and interval notation. So again, we're going to come over here to this problem and we're going to ask ourselves at first, we say, is the absolute value isolated? And yes, it is. And second, is it reasonable? Can the absolute value of x plus 3 be greater or equal to the number 7? And the answer is yes. Once we know that it's isolated and valid, then we can set up the other side of this, right? We're going to take, again, we've got the x plus 3 is greater than or equal to 7. I'm going to mirror that over here. Notice the symbol's the same. And I'm going to do minus 7. And now that I set it up to this compound situation, I'm ready now to just expand it out, like to separate it. And this way I can get rid of the bars. So I say with these, I would always kind of separate them. And then again, I'm solving for x. So I'm going to get negative 10 and positive x. And over here, I'm going to get x is greater than or equal to 4. So when I look at these, I'm like, do I put them together like I did here? But notice that x, this makes sense that x is between 3 and 7. But here, this doesn't make sense because this is saying that x is less than or equal to negative 10 and x is greater than or equal to 4. So if I was to graph this, notice here's negative 10, here's positive 4, and what I'm really saying is that it goes from here this way, and this one is a solid circle here, and it's greater, it goes this way. So this is really like an OR scenario, like we talked about there. Notice that this inequality is greater than, starts out, and this one is less than. So again, when it starts out as a less than, usually it's an and scenario, and your solutions are in between the endpoints, right? When it's a greater than or greater than or equal to, it's usually an or scenario where your answers kind of go in opposite directions. Okay, so this would be negative infinity, positive infinity, and so how I would do this one is it's going to be negative infinity to negative 10, bracket, parentheses, union, and then 4 to infinity, parentheses. And so there's like two solution sets here, kind of, right? And so again, you got to be very, very careful, look at the numbers and see, make sure that they don't really, that they go opposite or that they intersect there. Okay, so we just keep going here. Again, we notice that the absolute value is isolated and it is reasonable. It's reasonable that the absolute value of anything would be less than or equal to a positive 4. So because again, it's reasonable, we're ready to solve it. So I'm going to set up this extra side over here, right? Copy the symbol and then do the negative. So I've got negative 4 is less than or equal to x minus 20. And x minus 20 is less than or equal to positive 4. Again, add 20 to both sides, and I get 16 is less than or equal to x. And here I'm going to add 20, and I get x is less than or equal to 24. So again, sometimes I just graph it out before I figure out my final solution. 16 to 24, I know that I'm going to have here a closed circle at 16, and x is going to be bigger than it, so it's this way. And I have a closed circle at 24, and x is less than it. And so I can merge these two solutions together as this, if I want to, right? Or I can just do and, like that. And then the last thing is, how would I do this in interval notation? So it's, again, from 16 to 24, and it includes the ends. And so we keep going to number 12. Now in number 12, you're going to notice that you have here a negative 3. See, my absolute value is not fully isolated, and so I can't even start doing my the other side and negating or any of that until I get rid of that. So I have to divide both sides by negative 3. Once I do that, I'm going to get the absolute value of x minus 1. Because I divided by negative 3, I have to flip my sign, and I get 5. So now that I did this, I ask myself, is it reasonable that the absolute value of x minus 1 would be less than or equal to 5? Yes, it's reasonable. And if it's reasonable, I'm ready to do my matching inequality and my negating. So I'm going to go to negative 5 is less than or equal to x minus 1, and x minus 1 is less than or equal to positive 5. Add 1, add 1. So negative 4 is less than or equal to x, and I get x is less than or equal to 6. So when I come over to here and I graph this, I have a -4, +6, and notice that it says x is bigger than -4 or equal to it, so it goes this way, and x is less than or equal to 6, so it goes this way. And so I know that this is an and scenario, which means, again, I could just do this, which is probably a better way to write it, right? And then in interval notation, it's -4 to 6 with brackets. So this last page is reserved for all of our special cases, okay? Because again, absolute values are very special in that, for example, absolute values are always positive. So look what happens with this one. So these are special cases, okay? And they're tricky. And so again, in this page, they're all together, but these could be given to you at any time. So always ask yourself the same thing, like I've been doing throughout. Is my absolute value symbol or sign, is it isolated? No. So right now, I see this -2. So I'm going to have to divide both sides by -2. So this is going to be the absolute value of x minus 1. Because I'm dividing by a negative, I have to switch the sign, and the answer is -2. So now before I go to solve this, ask yourself, is the absolute value of x minus 1 greater than or equal to -2? Well, an absolute value sign, okay, or an absolute value of anything is always positive. Well, if it's always positive, then it's always going to be greater than or equal to a negative number. So this is kind of like an infinitely many solutions. In other words, any value for x is going to work here because the absolute value of anything is always bigger than a negative number. So when we have infinitely many, one of the ways we write this out, okay, is we do -infinity to +infinity in interval notation like that, okay? So that's kind of interesting there. That was one tricky one. When we go to number 14, we sort of have the same thing. Another trick. We isolate here. We've isolated our x minus 1 absolute value, so we're good there. So now we ask ourselves, can the absolute value of anything ever be less than or equal to 0? Well, guess what? It cannot be less than 0 because that would mean that it would be a negative number, and the absolute value is never a negative number, but it can be equal to 0. So there's only going to be one value here that works. Every other value is going to make this greater than 0, and it's going to make it false. So we need to figure out, well, what value is going to make this equal to 0? And we add 1 to both sides, and we're like x is 1. So the only thing that works here is when x is 1. If x is anything else, we're going to be always greater than 0, and it's not going to meet the criteria here. So we have one simple solution. So obviously on a graph, that's represented by just a dot. In interval notation, we just do this, okay? And we just do 1. We go to the next one down here. Again, your absolute value is isolated, which is what we want. But then we ask ourselves, is the absolute value of 2x minus 1 less than or equal to 0? Well, once again, it cannot be less than 0. However, it could be equal to 0. And so we're going to find that one solution in this entire problem that works. And we're going to get x is a half. And so again, this is the only solution to this problem, okay? Because any other number is going to make it greater than 0, and that's not going to work. And then here again it says 2x minus 1 is greater than 0. So we ask ourselves, does that make sense? Is the absolute value going to be greater than 0? Yeah, it's going to be greater than 0 in every single case except when it equals 0, right? It's never going to be less than 0, but it could actually equal 0. So again, we say to ourselves, well, when would 2x minus 1 equal 0? Well, it's going to equal 0 when x is a half. And so what we know is that x then cannot equal a half, because when it equals a half, it's going to be equal to 0, and that's false. Any other value, all other values are going to work. So how do you represent everything but a half? Well, first of all, if we came over here to the graph and we had a half, we would have this open circle and it would go up and to the left and it'd go to the right, just not including it. So in a graph, that's how we would show that. In interval notation, it's kind of neat how we show it. Remember, we're going from negative infinity to positive infinity. So we do negative infinity, right, to 1/2, not including 1/2, union. Well, it doesn't have this little thing, sorry. It's just like this. And then again, from 1/2 to positive infinity. And so basically what this is saying is from negative infinity to 1/2, but not including it, and then starting at 1/2, but not including it, to positive infinity. So again, these are quite tricky. You got to be very, very careful, but you're not going to know if you're dealing with these tricky ones. So every single time you reason out an absolute value equation or inequality, you've got to really think about, can my answer be less than something? Can it be greater? Can it be even? Can it be 0? And it's a very, very tricky, these special cases. With practice, you'll get good at recognizing them.